Okay, welcome everyone to my talk today on brain fucking with Raku AST. And just kind of as an initial note for this talk, Raku AST and slang content in these slides are current as of today. Some details may change. So like I talked about yesterday, there's still a little bit of work being done on slangs and how we create them. And Raku AST in particular, it's probably, I think, about 70% finished. So this is kind of a little bit of a preview of it, but some details change. In fact, as I was going through and writing this talk, I found that the way that you declare a variable changed a little bit. And so now I'm going to go back and change all of my modules that I've written with it. So it will happen to everybody, but just be ready for it. Oh, and I typoed my own name. Wonderful. Knew there'd be a typo somewhere. All right. Yeah, just go ahead and get the first one there. All right. So parsing brainfuck. What is brainfuck? I feel like I also need a little, if anybody saw that South Park episode where they have a little counter for the number of times that they say shit in it, I feel like I'm going to need that for this talk. So what is it? It's an extremely simple Turing-complete language. It only has 8 commands. And really, we can almost think of it just 6 plus a loop control. So it's extremely more basic than basic. And all we have are these 8 characters that have any meaning in the language. We can shift a pointer left. We can shift it to the right. We can increment a value or decrement it. And we can output, and we can grab a data point from the input. And then we have a block that basically functions like a while block with a single value in it. That just terminates once it's a 0 with no other control. So why would I talk about brainfuck at a Perl and Raku conference? Well, it can have less line noise than Perl. Okay. Please note, only valid for well-written and commented BF code and script kitty golf Perl code. Okay. I like Perl too. Promise. But also, it's really simple to explain and simple to interpret. Even if for this talk I wanted to use BASIC, I would have to go into far more details about how you do operator precedence, how to do, a much deeper level of grammar parsing. And this talk is not really about using the grammars in Raku. So while I'll get into it a little bit, the idea is to kind of avoid that and really focus on the Raku AST part. But at the same time, it has enough details in it for how it works that we'll be able to see how you would use Raku AST, or at least get your feet wet while working with it. So first step is going to be to find the grammar. And of course, Tim Tody applies here. There's a lot of different ways that you could write a grammar for brainfuck. This is probably as simple as you can get for it. So you just have a top token. There's just a set of commands. And the commands are those ones that we had. And one of those things some people might get frustrated with when you use that little symbol one with the arrows. If you need to use an arrow in it, use the double arrow. And that way you can actually put them in there. And then you have this junk data here, which is anything that's not one of those. But for the purpose of this talk, we're going to do one site change to that one, and we will do the loop as a single one. Per the original setup for brainfuck, you have to terminate your loops. You can't leave one open, so we might as well go ahead and enforce this correctness at parse time. Also, as we'll see, it allows a true optimization, because if you do them all as individual commands, then the definition would be when you hit that end, you have to scan back command by command by command to find the start point again. But here we can just turn it into a loop. So hopefully this is okay grammar. No one's too weirded out. Everybody's kind of seen them before or mostly understands it. So I think the next step is we want to imagine what our Raku code would be. Because ultimately, anything we'd write with Raku AST is going to be converted into Raku code. And so it can be helpful to go the other way. So if we have these two commands that just shift our pointer, well, we could imagine just pointer plus plus, pointer minus minus. and pretty straightforward one. Similarly, if I had the plus and minus, how might that one look? Well, we'd have our memory, whatever memory we're using, whatever structure we're using for that, at the pointer location, and similarly, plus plus, minus minus. But IO, because there are those two IO commands, well, same thing. Let's shift in from our input, or we can push onto our output. And of course, there's a lot of different ways that you could do this, right? We have the defined in and outs. You could maybe want to use that depending on how you're going to actually structure your program, right? Again, TimTody really applies here. Lots of different ways that you can handle it. But this will be the approach that I'm going to use within this talk. And how might we imagine a loop? So just to kind of give us a little bit more structure, if we had the brainfuck code plus, 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 and then a loop of just minus. So all we do is we increment the first value 3 times, and then we do a loop while we decrement it until we get down to a 0. Okay? Really straightforward. This is why it's a really easy language to work with. All right? So we have just memory pointer, increment it 3 times, and then while, very simple while statement, and just decrement. And as anybody who's ever written a brainfuck interpreter knows, really it's almost a matter of just copy paste, right? If you can take these, you can just go line by line and just do a substring substitution, and you probably will end up with a very valid program in most languages, maybe with a little bit of boilerplate around. But this set of commands are what I'm going to be working with again in this talk. And so we will learn how to write all of these in RakuAST, as well as the sort of header and footer, and also wrapping it into a sub, and then finally packaging it up into a slang, again, to continue what I was talking about from yesterday. So what about those variables that we had? Right? We put in quick little boilerplate, right, of my pointer equals 0, start us off there. We'll do memory, output will be buff8, our input also, which we could just set to that, or a parameter called input. And again, that's what I will do ultimately, is just create it as a parameter here. And then at the end, you can just output it directly to whatever your standard out is, or you can return it if you're going to wrap it into a function. And again, I will do that latter one. We'll return it in this code. But again, super simple, right? And then you just wrap it into a routine. So here we have like anonymous sub. You see our header, then that footer, and that is ultimately what we'll be doing in this code. Everybody, does that code all make sense, everybody? No? Okay.
The double colon. It's too early in the morning.
No, double colon is just sort of an anonymous sub. You're not giving it a name.
You just don't give it a name.
I like to be specific about not giving it a name.
Okay, that makes sense.
I'm explicitly telling I'm not giving you a name. Yeah. Yeah, and actually in my code, I'll do that. There's some ways that you could give it in one, and I think for best practices, you should, just so the sub note has a name if you do any introspection or anything on it, but just for here. Okay, so let's actually get to RakuAST. Here we have a very simple line of code. And one of the things that working with RakuAST does is it really helps you understand what is going on in Raku, how it's parsing your code, and a lot of other stuff that goes on under the hood. So if for nothing else, playing around with RakuAST, I think just makes you a better Raku programmer because you understand what's going on at a much more in-depth level. So we have this statement, and this whole little area is a statement expression, right? And in RakuAST, this is how we're going to notate it. And I apologize, it can be a little bit verbose. So on the screen, it's maybe not going to be super large, but I will get these slides posted up online. And the entirety of this code is already posted on GitHub. So we have a Raku statement expression. So your core level is going to be those statements. And then we just have a single named parameter in there, which is expression. There are other named parameters you could get, but for probably 99% of the time, it's just going to be plain old expression. And then within the statement expression, Well, we have a variable declaration. Okay, and our code for there is just going to be RockwayAST var declaration simple dot new. And it's going to take a couple of arguments. The scope, which is my, which is the default. So technically you don't have to include if it's my. If it's anything else, you do. We have a sigil, right? In this case, $. We have the sigil name. This is what changed and broke all of my old code. It used to just be name, and you would use with the sigil in it. But now you actually have to do it separately. And the sigil, the $, D sigil name. And we have this name type, which is just, we create the name from an identifier, which in this case will just be pointer. And then we also need an initializer because we're starting it with a value. If you just wanted to declare it as my pointer, semicolon, then you wouldn't need this initializer. But we're going ahead and doing that. So the initializer, we take an assignment one. There's also a bind version of this one if you want to bind initially. So we'll create that one in here. And there we have our value, which will be an int literal. So when you're working with RockwayAST, you have for the literals, you have an int literal, you have a num literal, and then you have a string literal. And most everything else you'll be creating up from other statements. So, any questions at this point? Please stop me if there's anything that you need a little more time or explanation on. Okay, so that's our initial one. And you'll probably be telling me though, but that's a lot of different classes to remember. I'm not going to remember how to do all those different commands. Well, just do that. Throw it into a string, say my pointer equals 0, and then call .ast on it. And that's what you'll get out. Actually, I think if I remember correctly, it actually is wrapped in a statement list, but that's just one more level of encapsulation on it. But this is really helpful when you're going through and you're like, I don't know how I need to do this one, but I know my code needs to end up looking like X. So you just type in x.ast and you get it. So this is super, super helpful as you're learning to instantly see, or honestly, sometimes if you're kind of debugging your code and you're like, I don't understand what's going on here, this is a quick way to say, hey, Raku, what do you see? What do you see in my code? All right, so next, what about our memory and output that we have? We need to have those buffs in there. Well, unfortunately, right now that trait of isBuff8, right, where we type the array, not the value of the arrays, but the actual class of the array itself, isn't yet handled in RockwayAST. So for the moment, we'll just actually create it in a scalar value because we can type that, right? Or at least we can put in something initially with it. And all will be well. So, how would we do this? Well, we want buff8.new. And now we have a couple new classes in here. We have a statement expression like we had before, but now our expression is apply postfix. And you might not be thinking of this code as having a postfix in it, but we actually consider the call method to be a postfix on it. So that little dotty, it's a dotty postfix. And so we get our postfix is call method, and its argument is the name of the method that we're calling, which is new. And then we have our operand, which is what are we calling that postfix on? And that is the type buff8. So we have a type simple, because the alternate to the type simple would be a type parameterized. And so most of the time, again, you'll probably just use simple. And again, we just call it by its name. And again, initially, if you're doing this, you might think, I have absolutely no idea how to do this buff8 new. But again, that .ast really helps for getting a hold on it. But that's a lot of code. Because you think we've got to take this initial declaration, and inside of what we have here in the initializer, now we have to put the entirety of that buff8 call in there. So what's easier is, that's what we get. These are now gigantic bit of code. But you can always store a node into a variable. So I can take that whole apply postfix to get the new statement on buff 8, and I can just throw it into a variable, new buff. And then we can reuse it anywhere. You don't have to have a new call and get a fresh copy of it by calling a .new again for each time that we're going to use it. We can absolutely reuse it, which is a great way to save, make your code more efficient, and then also make it more readable. So now, when I have my two declarations for memory and output, you can see there under the initializer, I just have the new buff. Actually, that should be wrapped in an initializer. That was my typo here. Knew there'd be another one in here. But again, saves you time. And I like to store these statements or groups of statements into variables, especially when I'm working with loops. Yes?
I got suddenly, if you said this right, but for the sigil there, previously you had memory with a at sigil.
Yeah. Okay. So the question was, I had memory for the at sigil for listy stuff. The catch is that you can't right now with RockwayAST, you can't type the array. You can type the values of the array, but when you say like array, at array is list or at array is buff 8, that is buff 8 or is list is not supported in RockwayAST yet.
Does RockwayAST support binding? Like if I were writing regular.
Yeah, I could probably have done that too.
At sigil bound to.
Yes, okay. You could do that. I was wanting to kind of keep it a little more simple, but I probably ended up causing a little confusion there too. Okay. Sorry about that. But yeah, so we're just going to work with them all and with the scalar bit. Okay. Everything else works the same. Okay. So I like to keep my life easy. So I store all my statements or a lot of statements into variables for loops or other places especially. So what I would do here or recommend is to say, hey, my pointer declare equals my output declare, my memory declare. And you'll see later on in this talk where that's going to make some stuff visually much more appealing and kind of show your code logic off to yourself in a very nice way. So now let's take a look at our postfix addition and subtraction, right? And just see how we would do that. So we'll start with our pointer one because all that one was just increment and decrement the pointer. So we got these two. And we end up with a statement expression. And all it is, again, apply a postfix. And what is our postfix? Well, plus plus. And so if you need to call on a postfix, whatever that is, all you need to know is the string of it. And so RockwayAST postfix.new plus plus or minus minus accordingly. And then your operand, whatever that is. And if you're generating this code dynamically, right, you can just plop in a variable there instead. And it will create that postfix based upon whatever the contents of a string variable is. So again, possibilities here for doing some really crazy stuff exists, but ours keeps it a little simpler.
Does it matter that returns, the vacuum postfix returns the value?
No, so we don't have to worry about that, whether it returns 1 or not. Because ultimately, if you think whatever we have in our Raku code, so the question was whether it matters that this returns value or not, and it'll depend on the context. So because this might end up going to a sink, it might just be, that might be the end of the statement, and then doesn't matter. If it's at the end of, say, like a sub block, which eventually we'll be wrapping all this into a sub block, it's the sub block that handles that default return value. And so the final line doesn't have to know that its value would be returned.
But I guess does brainfucks plus return a value, or does it just do a side?
No, because it has nothing. It doesn't have any concept of anything getting returned.
I guess what I'm asking, it doesn't mess us up that we're returning a value in this code, even though brainfuck is not returning.
Correct. Yeah, because effectively, each of these statements, I could just put sync.
Okay.
So if that helps kind of conceptualize it, just put sync in front of every single one of these statements. We don't need any more. All right.
It shouldn't matter whether it's prefix or a postfix for the decorated word.
Exactly. Right. So the comment was here that it doesn't actually matter whether it's postfix or prefix, increment, decrement, and exactly right. We could do the other one. And how would we do that? That's a very thank you for giving me a great question to the audience. How would we make this a prefix one instead?
Well, I imagine you would supply the prefix instead of the postfix as an argument there, right?
Exactly. We'd have apply prefix and then generate a new prefix. And so once you kind of get the hang of this initial structure, it builds up really fast. Infix, we'll see an infix here later on as well. So here we've got a little bit more involved statement because we want to be able to actually work with our memory and pointer. And again, lines of code like this show us actually how concise we get things in higher level languages, because there's a lot of stuff going on here, right? We've got to first, you imagine, we got to grab the pointer from the memory, but we really have a set of arguments inside of these braces, because that's really sort of effectively a method call in Raku, because you could have inside the braces multiple values. So we're going to start with just this section, because you already know how to, at this point, do the increment of a value, and nothing will change with that. All we need to do is change our operand. So this is what we get. We get an apply postfix, and our postfix is going to be the post circumfix array index, okay, which thankfully that's kind of already made. But also, again, Tim Tody applies here. If you wanted to, you could go back to what we had earlier, where we saw that method call, and you could just do the method call at position, and that would work too. I don't know if there's any particular advantage one way or the other, but you can if you wanted to. But we get our postfix but you notice now it has an index value, and the index requires a semilist. Why a semilist? Because we could do semicolon delimited ones here for a multi-dimensional array. So it takes a semilist instead of just a plain old list, because you could have that like list within list thing. But then we end up with our statement expression again, and we have a pointer, right? But if you throw that into, say, a value like memory location, that we'll save it into a place called memory location, then notice how much simpler this expression looks. All we have is apply a postfix operand. Very concise, very readable. Okay? Now, what if we want to assign from the input? Again, this is our statement. We've got that memory location that we've already written the code for, and we just need to assign it in from a shift call from memory. So let's define first that memory shift, apply a postfix, and what's our operand? Just that variable. Oh wait, that should be type symbol. That should just be the variable lexical. I knew there'd be another typo in here. Then the postfix will just be that method call, and we'll shift the value off. So again, typo here, that operand should just be the var lexical memory. And now our expression, because we have that memory location saved, we already wrote that code, no need to double up our work. We have the memory shift one. Now we end up with this very, very simple statement with a single apply infix with one F, not two. Now we'll also need to call a method with arguments. If we're going to output, we need to do that method call push, but we need arguments. And so you can see how that one would work. There's another name called args, when you create an argument list, and then you just list each value that's going to be passed to that argument list. And arg list will handle how those arguments are converted into positional versus named arguments. It'll handle the slipping in of the arguments if you pass in a slip. So we don't have to worry about any of that. We just provide that. You can almost think about what would you have had in those parentheses, what would you have typed out each one. You just dump them here and everything will work. So next we'll go through the actions, right? Because we have our grammar. So now we'll create an actions class, and we've created all of these statements, and we'll just make each one of them inside of our actions. So those of y'all who are familiar with the way that grammars and actions work in Raku will know make is sort of the default way to pass information between tokens in the AST construction. So for instance, for this shift one, right, we'd have method command with the shift pointer to the right, and we just say make Raku AST statement expression, and you put in that. And so that becomes their whole action method. And again, if you use a lot of reusing, so if you look at some of my modules that I've made in the past, there's not anywhere near as much noise in here, because like the Raku AST postfix plus plus, I just save that to a constant. And so it just says postfix increment or something like that. Or all my variables, I go ahead and pre-declare all my variables. So I would just say operand pointer. And then it's much easier to kind of quickly reason through my code and doesn't extend out way past the edge of my window. And then of course, all these we can use with made in the end. So how would we make the loop? And we do all those other ones because this one is going to actually have to use some of those previous values. So we have this while. We're going to now have a different statement type. Previously, we've been using statement expression. Now we're going to have a statement loop. Specifically, statement loop while. And again, how does a while loop work? We have a condition, right? Our condition here is thankfully, mercifully, very simple. It is just the value at memory location. If you want to do a more complex one, you could put in apply infix here and say, hey, if it is equal to 0, put in apply infix, have our infix value be an equal or numeric compare equal. Our body, this is one that can be a little strange at first because our body is a block, but then inside of the block, we have a blockoid. And then inside of that, we finally have a statement list. I will admit to still not fully understanding the difference between a block and a blockoid. It also is not super important. If you ever have one issue with one, you just add in the blockoid or add in the block accordingly. Hopefully, as we get this more dive, it'll be a little bit clearer when we need one or the other. It has to do with what sort of other attributes can be given to it if you're doing like which ones can take a $sign underscore. So that's what changes a little bit in there, or which ones can take arguments and have parameter lists. But yeah, so you get this blockoid in the statement list, and then all of your statements go in. And this is where I was saying it can make your code, if you take all of your kind of core statements, if you're doing a loop like this, it's really beneficial to store them all into a variable. Otherwise, where I have statement A, statement B, you're going to have these very, very large blocks of text, which is not fun to work with. Now, to fill in the loop, this is just kind of a little bit on the action side. If we have all of our commands, how would we fill in those commands into the statement? Well, we just do my statements equals command dot map, and we grab the made from every single one of them. And now we have our, make that loop, and again, fill in all the code from the previous one, but just use a slip for the statements. So make sure to put the pipe in front of the statement for command. And oh yeah, forgot, we have the junk, right? Because in Brainfuck, only those 8 characters are valid syntax. Everything else is considered a comment. But we still have to make something. And what would the code be for that? Nothing. There is no Raku code for that. But we still, again, need to be able to call .made because it is a command in our method. So we just make empty. And when we do that mapping, this empty just disappears. So we don't have to worry about, we're not going to have a nil value in there or some untyped value or anything that's going to screw up our code. It just disappears. It's one of my favorite little things to just slip into code. Lastly, we'll need to generate the sub. Subs are made really from 2 primary parts, a signature and a body. And they also have a name element. So here we'd have very simple, right? We'd have a signature and a body. And I'll get into now just in a second what those would look like. So our signature, if we want to have a single buff8 input, right, which is what the signature would be for a brainfuck routine, we have our signature, we have a list of parameters, and in this case, we only have one parameter. We type it, right? Call that type a simple one just from our identifier of buff8. We have our target, which is what do we want to input that value into, right? Other attributes that you might have here or other argument values you'd have here might be for having those aliases. You could set those up in here. And then in our case, we're gonna do optional true because, maybe we don't have any input. Not every brainfuck program requires input, so why require somebody to pass it? And then in this sub body, this is really where you see the usefulness of storing everything in variables, because now I can just say block void statement list and then just list. And I see that reasoning in my program. My 3 declarations, slip in the statements, put in the output return. And the output return is just put the value and you're done. There's a couple of things always when you're writing grammars and actions, double check, make sure everything return their data via make, because if you just put a return in those methods, it's not really going to do anything. And also for how we do it, make sure any of those shortcut reference variables, you set them correctly, that they do refer, in fact, to what you want them to refer to. These are just 2 things that I kind of get sometimes when I'm writing code. Now that we have everything, we've got our sub made, we've filled it in all the statements, everything, we've created everything that we would need if we wanted to assign to a variable and run it. That for me is not enough. I want it in a slang. I want to be able to use this inline. So how would we do that? This is a token that I use for my basic slang. So if y'all were here last year, I did that in my lightning talk. This is a little bit more complicated one because I handle an arguments list and everything. But we can still use it for the basic idea that we will create a routine declarator and you create a symbol for it, which in this case was basic. And so it would have basic and the keyword, and then allow some white space, the name of it. And then at the very end, there are some braces, and then our actual token of basic, which is where all the basic code would go. So how would this look like for brainfuck? Actually a lot simpler, thankfully, gracefully. We just have our symbol, which would be the BF, our name, whatever that would be, and then insert our BF code there in the middle of it. And so that's kind of an important thing to point out, that we created our grammar with it named top, because that's what you would do normally for a grammar, and it makes initial development really easy. But once we're moving into that slang world, we're going to need to rename this. And that is because we're going to be mixing in to the main grammar. So that's not the only modification. There's a couple things that we're going to do, and it's because we're mixing into main. Because as I talked yesterday, this is currently sort of the way that most people write slangs, is just to mix in and modify the main language. So first thing, very important, we need to ensure that the slang terminates at some point. And in the case of brainfuck, that means we also need to make sure that the closed brace is not considered junk. The closed brace will actually terminate our block. So light kind of modification there. We also need to change our grammar and action classes to roles, because we will be mixing in now. So instead of grammar, whatever as their initial one, or class actions, both those will just become roles. And then this is the one that annoys me the most about this. We have to do old school prefixing, because there's a very high likelihood that the token names that you used when you wrote your grammar are going to overlap with at least one token name in core grammar. So what I just do, like top BF, common BF command, junk BF junk. And it's a little annoying. It adds some extra work, but it is what it is. So next we'll create our mix-in module. All right, we have this polyglot. I just stored these, for instance, if you look at this code online where I stored it, I just called those modules polyglot, brainfuck, grammar, and actions, as tends to be the pattern. We define our slang, we mix in our grammar and our actions into the main grammar and actions, and then return an empty map because we're not actually exporting symbols. And now we can run our code. So I don't know why this is useful to do, but hey, here we have BF add 2, comma plus plus dot. And again, the only catch here is we do have to do a buff8 as our input. So buff8 new 40. And when this pops out, we get a buff popping out, and it gives us the value 2a, which is 42 in decimal. So we know that our code works. It's a very simple test case. Let's maybe go for a more difficult one. Or sorry, before we do that, in the background, this is actually the code that's generated. Minus the name one, I just did that for the presentation. But we created buff8 with an optional input. We get our pointer in, our memory in, output in, set all those up. We shift over, we increment twice, and we push it out, and then we return it. So this is our generated code from this very short snippet of brainfuck code. Obviously, with brainfuck is not a very useful language. You can imagine where creating some other DSL that might be germane to whatever work you're doing, generating code like this in the background that is purely Raku code could be really useful. Or you do this one, a little more complex one. And this is a very well-known, which is the hello world. And again, we return a buff, and this is returning ASCII data, so we do to decode first, and then we get our string value, and we get hello world. So, what did we learn today? Hopefully, since I didn't hear a lot of questions, I assume everyone followed mostly. You learned how to create statements in Raku AST. You defined and referenced variables in it. You applied infix, postfixes, post-circumfixes in it. And of course, we also figured out how we could do a prefix if we wanted to. Generated subs with their signatures. Create a very simple programming language parser. And technically, I guess we can call that a virtual machine that we made. I mean, it's a very simple one we did in Raku AST and grammars. And we also created a slang while avoiding our name clash issues. So what could we do in the future with this? Right? Like I said, I posted this online, so you can go and download and take a look at it. But if you want to play around with it, there's a lot of different things that you might want to think about doing that we didn't handle here. What about ways to set the size of the cells? Would you want to do that somewhere in the declaration where we have BF and maybe add a number right after it, BF8, BF16? Would you want to put some syntax inside of the BF block? It's up to you how you would want to do it. Would you want to do signed or unsigned? It's actually generally signed that you use, but I used unsigned just because it made it a little easier. What about limiting the size of the memory? A lot of brainfuck programs are designed to assume a certain memory value. And then if you have a negative pointer, some of them will wrap around. Right? Others just allow negative pointer values. How would you do that? Also, how do you handle end of file for input values? Because I could write a cat program that just parrots back the data, but how I have it currently done, there would be no way to know when that input terminates. Or it actually would crash it because the input would start giving any values, which wouldn't work probably. Or maybe have errors if you include a signature, because we don't want a signature. So when you're doing these, right, Raku really tries to have good error messages. So what error messages could you throw up to people as you're parsing that grammar or as you're running to give them something good? You also add support for the standard eval function. So that somebody could just say eval, lang brainfuck, and just do that in place wherever they need it. Or optimizations. There's a lot of idioms that are used for like adding two values from a pointer. Within our grammar, we could actually catch those patterns, recognize that what they're really trying to do is just add two values from two different pointer locations and optimize it with a simple Raku add one that grabs those two locations from memory and doesn't have to constantly increment by one. So there's a lot of stuff that you can do to play around with this and learn about Raku AST at the same time, and also about other ways to make some nice modules. So if you want to play around with it, you can find it on GitHub. It's already posted. as of about, I guess, 40 minutes ago. And so before I end it here, just a couple of my pieces of advice with Roku AST. Be excited about it. There's a lot of really fun stuff we can do, but prepare for changes, as I had when I wrote this talk. Reuse, reuse, reuse. It can get verbose, all right? But here also, you notice we're writing fairly large blocks. The actual Roku code, you can imagine, most of them will just be creating one tiny little thing and then just all getting built together, built together, built together, the more minute your grammar is. But you reuse as much as you can. The test files in Roku Core or Rakudo compiler are a really great guide to see how stuff should work. So if you go look up Rakudo source and you go into the test files, I think it's 12 is the numbering for it, and it'll be like 12 Roku AST, and you can pull up how to do a whole host of different things if you're not sure. But also AST and dparse are your BFFs. Okay, we talked about AST. Dparse is the opposite. Dparse will attempt to take a Roku AST object and generate the code that would have produced it had you done AST. So these two should round trip each other. So, any questions, comments, complaints? Yes.
Two things.
Yes.
First, the repo URL that you may have set to private, I get 404.
You're 405. Okay, I will fix that. So the question was that the repo is not working right now. I will fix that.
Second thing, maybe you covered it and I missed it. We want to do something very primitive to what you're doing. All we want to do is take something, dump the AST to a variable, and then invoke that. What did I miss? Of just, I've got an AST to variable. Do I do a dot paren after it, or?
Oh, so to invoke the, actually, I think I did miss that in the slides. It is in the code that was posted, that will be posted, was posted. So yeah, what you do is eval that Roku AST block, and that will run whatever's in the code there. So it'd be the equivalent of running the string version of it. You also do need to right now use experimental Roku AST at the start of any code that uses it. Yes?
So on the verbosity point, you might have been doing this just to teach us, or I might be missing something basic, but you showed how you can use .ast to get a statement list. Couldn't you just have the string .ast pull out the first statement and not need to type?
Yes. So the question was, could you in a lot of cases just type in a string version of something, type .ast, and then pull out the first statement or whichever statement you want from it? And the answer is yes, you absolutely can do that in a lot of cases. And actually, this is where I think Roku AST is going to be really fun, is we can grab those or grab somebody else's AST they've had. You can then traverse it, find things, and edit right within those. So yeah, you could do that and be like, well, I have this placeholder, let me find that, and then I'll insert, instead of this one, I'll insert my other gigantic Roku AST block based on the production of .ast. Yes, absolutely. But I like doing it by hand so you can see everything. Yes. Okay. Any other questions? Okay, well, thank you all for coming.